right, so 6-6 is about trapezoids and kites, and I'll be honest with you guys, this is one of the sections that I really had to teach myself. A lot of the sections and the lessons I can either figure out without doing too much reading or looking into it, or I just remember from my days back in geometry. But this one I really had to put a little bit of effort into, kind of teaching myself. There's kind of a lot of good stuff in this section. Also in this section, there's a lot of requirement of prior knowledge from previous sections, like how to prove triangles are congruent. We're going to have to do that today. Properties of parallel lines. Isosceles triangles. So we got kind of a lot of fun stuff in this section. I really like this section, but there's kind of a lot to it. So first, we're going to talk about a trapezoid. So a trapezoid, quadrilateral, so it has 4 sides, but it has to have exactly one pair of parallel sides. It's not like optional. It has to have at least one pair of parallel sides. It has to have exactly one. It cannot have 2 sets of parallel sides. So the parallel sides are called the bases. Okay, so in this case, it'd be that top and the bottom. The other 2 sides are called the legs. Now, what we're going to refer to a lot today is what's called the base angles. Now, the base angles come in pairs. And you can't just pair up any 2 of the angles. They have to be the angles that share the same base. So like these bottom 2 angles are a pair of base angles, and these top 2 angles are a pair of base angles. You couldn't pair up the left 2 angles. It's not going to work with what we're doing with theorem 619 down there. So the base angles, like I said, come in pairs. Now, if you so happen to have a trapezoid where the legs are congruent, so this picture, they obviously are not, but it does happen. If they are congruent, it's called an isosceles trapezoid. And that's what these 2 theorems, your trapezoid theorems, are referring to. So a quadrilateral that just so happens to be an isosceles trapezoid. So notice we have our parallel top and bottom, and then the legs are congruent. If you have an isosceles trapezoid, what theorem 619 tells you, it says the pairs of base angles are congruent. So this is why it's really important to be able to pair up the correct angles. So these bottom 2 angles are congruent to each other, the top 2 angles are congruent to each other. But you can't pair up like the left angles and the right angles. Okay, so they have to be the angles that share the same base. Theorem 620 talks about the diagonals. So the diagonals, kind of like the diagonals of a rectangle, the diagonals of a trapezoid are congruent. Okay, now, Theorem 621 talks about the mid-segment of a trapezoid, which I put the definition up here. It's a segment that joins the midpoints of its legs. We have talked about mid-segment this year already. We talked about the mid-segment of a triangle. So if you have a triangle, if you were to find the midpoints of 2 of the sides, so maybe those are the midpoints of those 2 sides, if you connect the midpoints, that's called the mid-segment. So when you do that, if this is the midpoint, it means those are congruent. And if that's the midpoint, it means those are congruent. So you can do the same thing with the trapezoid. So if M is the midpoint of RT, N is the midpoint of AP, means that those 2 are congruent and those 2 are congruent. This MN is the mid-segment. So the mid-segment, there's 2 things that this theorem tells me that we can conclude about the mid-segment. First of all, this is going to be really handy. The mid-segment is going to be parallel to the other 2 bases. So that's going to be handy because remember with parallel lines, we have all those angle relationships, alternate interior, alternate exterior, corresponding, same side, all of those things. Since they're parallel, that's going to be really handy there. But the other one that can be a little tricky, and we're going to do quite a bit with this today, when it says MN, remember since there's not a line over top of it, it means it's the length. So this is saying the length of the mid-segment. If you want to find the length of the mid-segment, you're going to take half the sum of the bases. So what you're going to do to find the length of the mid-segment, you're going to add the top and the bottom, if it's set up that way, divided by 2. That's the length of the mid-segment. So kind of, as far as the formulas we've talked about this year, kind of a complicated formula, but we'll take it slow. So like this one right here, it says QR is the mid-segment, which implies that those are congruent and those are congruent. I want to find the value of x. So what that me, it says that the mid-segment, in this case, x plus 2, equals, to find the length of the mid-segment, you're going to add the bases together. Now, if they're just numbers, if it was like 5 and 6, you take 5 plus 6, that's it, okay? In this case, it's not just numbers, it's 4x minus 10 and 8. But you do the same thing. You take 4x minus 10 plus 8, you'd add them together. So, 4x and then negative 10 and 8 would be 4x minus 2. The mid-segment is half of that. Half of that. So add the bases together, divide it by 2, or usually what we're going to do is multiply by 1/2. It's the same thing. And then we can go ahead and solve for x here. So the big thing, you have to take half of the entire sum. You can't just take half of 4x. You have to take half of the whole thing. So that means you're going to have to distribute the 1/2. So if you x plus 2 equals, half of 4x would be 2x. Half of minus 2 would be minus 1. And then to solve for x, subtract your x from both sides. So 2 equals x minus 1. Add 1, we get x equals 3. So that's one of the things we're going to be doing today, is using that mid-segment formula to either solve for x or find distances. Okay, the other quadrilateral that we talk about today is called a kite. And I'll be honest with you, I think the kite, to me at least, is probably the trickiest of all the quadrilaterals we've talked about. It just doesn't have quite the same consistencies. I have to think a little bit more as definitely rectangles, rhombuses, and squares, but even with the trapezoids. So what a kite is, it's a quadrilateral that has 2 pairs of consecutive sides that are congruent. Okay, so consecutive means right next to each other. So notice that this top left and the bottom left, those are congruent right next to each other. And then the 2 right sides are going to be congruent. But what's important here, there are no opposite sides congruent. So you can't, if it's a kite, you could not have opposite sides congruent, which means it has to be a parallelogram. So a kite cannot be a parallelogram. Okay? Now, if it's a kite, then Theorem 622 says the diagonals are going to be perpendicular. So kind of like a rhombus, right? The diagonals of a rhombus are going to be perpendicular. So here's your congruent sides, here's your congruent sides. If you connect your diagonals, the opposite angles, that's always going to be a perpendicular line. Okay, so we're going to put all of this to use. Let's get this glued into, should be page 13. And this is section 6.6, trapezoids and heights. So I kind of already told you guys this section takes a lot of prior knowledge, but at the same time, there's a lot of things in this section that you could say, well, I'm going to guess that this is how you'd find the answer, and you're probably right. But what we're going to do is we're going to make sure we go back and kind of justify, yes, that's right, but here's the prior knowledge that lets us find our answer that way. So first thing, we want to find the measures of the numbered angles in each isosceles trapezoid. Remember, an isosceles trapezoid has your parallel lines, which are the bases, and the legs are going to be congruent. So for number 1, go ahead and draw an isosceles trapezoid. So you have to have your parallel sides and our congruent legs. Now, in your book, or really anywhere, if it doesn't tell you that the top and the bottom are parallel, they tell me it's a trapezoid, so we can go ahead and assume that. Okay. So for this one, angle 1 is going to be the bottom right, angle 2 will be the top right, angle 3 will be the top left, and then the last angle is going to be 77. So I want to find the measure of all of these numbered angles, so I'm going to try to find the measure of angle 1, the measure of angle 2, and the measure of angle 3. Now, which of these angles is going to be the easiest to find?
No.
1. Why? Now remember, that's a parallelogram. For a parallelogram, consecutive angles are supplementary. For a trapezoid, this angle that's 77 and the angles that 1, these are base angles. What do you know about the base angles of an isosceles trapezoid? They're congruent. So angle 1 is also 77. Okay, now, we also know by the same reason that angle 2 and angle 3 are going to be the same thing. So this is kind of one of those things that if you were to just guess, how do you think we could find 2 and 3?
77 times 2 and then take half minus 360 and divide that by 2.
So that's what I did first too, right? We know that all of these together are 360 because it's a quadrilateral. So 77 times 2, okay, subtract that from 360 and then divide it by 2. That would be one way. That's what I did first. Would there be maybe like a shorter way?
Yeah, they like them corresponding.
They're
Same
not-
side interior.
They are same side interior angles. Remember, these are parallel lines, right? And if they're parallel lines cut by a transversal, these are same side interior angles. What do you know about same side interior angles? They're supplementary. So really all you need to do is take 180 minus 77, and you get 103 for both of those. So those parallel lines are going to come in really, really handy today. Okay, number 2, let's draw another isosceles trapezoid here. So we have our congruent legs. The bottom left is going to be angle 1, angle 2, angle 3, and that bottom right angle is going to be 49. And once again, we're looking for the measure of angle 1, the measure of angle 2, and the measure of angle 3. Which will be the easiest angle to find? 1, right? Because those are base angles. So what is the measure of angle 1? 49. And we know angle 2 and angle 3 are congruent. How are you going to find the measures of angle 2 and 3? 180 minus 49, which would give you 131. Questions on that one? Okay, let's move on to the mid-segment. Okay? Now, that formula that I gave you to find the length of the mid-segment does not have to be an isosceles trapezoid. So keep that in mind. That does have to have a parallel set of bases, but it does not have to be isosceles. It does, the mid-segment does have to cut each of the legs in half. So I know that side is cut in half and this side is cut in half. Keep in mind that all 4 of those aren't congruent. Those 2 are congruent segments, those are 2 are congruent segments. Okay, so this is going to be trapezoid A, B, C, D with mid-segment E, F. The top is going to be x minus 1. The mid-segment is going to be 2x plus 1. And that other base is going to be 15. Okay, as a reminder, the formula to find the mid-segment. The mid-segment equals, so in this case, 2x plus 1 equals, to find that, you're going to add the bases. So I'm going to take x minus 1 plus 15. So when I add the bases, what do I get? X plus 14. Now here's what you can't forget to do. The mid-segment is half of that. Half of that. Half of the entire sum. Okay, now, in my opinion, I think it's probably going to be easier to use decimals. So instead of leaving it as 1/2 x, I think it's probably a little easier to call it 0.5x. Means the same thing. I think sometimes we're a little more comfortable with decimals. And then half of 14 would be 7. Get your x's on the same side, so subtract 0.5x from both sides. So we have 1.5x plus 1 equals 7. Subtract 1, so 1.5x equals 6. When you divide by 1.5, you get x equals 4. Now, I think one of the biggest things today is you have to make sure you give your answer what they're asking for. So they weren't asking for x here. They're asking for EF. So what else do I need to do? Brianna? Which one? Right, plug it in. We're looking for the mid-segment, so we're going to plug it in right there. So we're going to take 2 times 4 plus 1, which would be 8 plus 1, which would be 9. So that kind of is just like an overwhelming thing when you guys get to your homework today. Make sure you're reading the directions. Make sure you're actually giving them what they're asking for. Okay, number 4. So we're going to move on to kites. Okay, I think probably the easiest way to draw a kite, draw the diagonals first. You know the diagonals are perpendicular. So go ahead and draw a pair of perpendicular lines, kind of like that. And then you know that these are congruent because it's a kite, and these are congruent because it's a kite. You know my experience drawing kites, my 2 days experience drawing kites. Okay, so we're going to say angle 1 is right here, angle 2, angle 3, and this angle is going to be 45. Okay, so we are looking for the measure of angle 1, the measure of angle 2, and the measure of angle 3. Now, one of these should be super duper easy to find. I'm going to pause on 1. 1 should be super duper easy to find because it is the diagonal of a kite. What do we know about the diagonals of a kite? They're perpendicular. So what is the measure of angle 1? 90. Okay. Now what you kind of have to do a lot today, you kind of have to look for triangles. Okay, look for triangles. And sometimes it's going to be like the little triangles, sometimes it's going to be like the big triangles. But what I see here is I have this triangle here. And I know this angle is 45, this angle is 90. Can I find angle 2? Yeah, right? 180 minus 90 minus 45. Angle 2 would be 45. Okay, now, let's talk about angle 3. If you were to guess, what do you think angle 3 is? I mean, that was like my original guess. I'm like, okay, it's probably 45. It really looks like it's 45. The problem is we have to justify this somehow. And I know what somebody in the last class told me is they said, well, that's a bisector. Do we know that's a bisector? Is that in our theorem? Don't know that. So what we're going to have to do here, we're going to have to use triangle congruence. Okay, so watch what happens here, because we're going to have to do this in the next problem as well. Okay? Now, it's not going to be the little triangles, because remember, in order to prove 2 triangles are congruent, we can either use angle, side, angle, side, angle, side, angle, angle, side, or side, 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 or hypotenuse leg. Okay, which I guess actually, we can do hypotenuse leg. Totally do hypotenuse leg. But I had done the big triangle. So I had done this triangle is congruent to this triangle. Anybody know what theorem we would use? What theorem of postulate would use? Side, side, side. So you have congruent sides, and then the shared congruent side. Okay, now why is that important? I have 2 congruent triangles. Remember the last section, beautiful memories, of triangle congruence where we did CPCT? Remember what CPCT stands for? Congruent parts of congruent triangles, which means if I have these 2 congruent triangles and I can say these 2 triangles are congruent, it means that all of their corresponding parts are congruent. Which means if this angle is 45, then yes, this angle is also 45. Okay, let's do, okay, now this problem number 5 is going to be a hot mess, I'm just warning you. Okay, so first thing, okay, draw your diagonals. It's going to be a kite, so just extend maybe off a little bit more to the left, and then connect top, bottom, and then here and here. And then remember, since it's a kite, we know that those are congruent. Okay, we're going to have 10 numbered angles here. The good news is the first 4 should be really easy to find. The first 4 could be right here. 1, 2, 3, 4. Okay, easy to find. Okay, angle 5 is going to be over here. Angle 6 will come over here. 7 and 8 will be those bottom two angles, and then 9 and 10 will be up here at the top. And then this angle right here is going to be 46. This angle right here is going to be 34. Okay, so I'm just going to go ahead and write that. We are looking for angles 1 through 10. So measure angle 1, measure angle 2, measure angle 3, measure angle 4, measure angle 5, 6, 7, 8, 9, and 10. Now we can go ahead and fill in almost half of these without even breaking a sweat. Which ones do I already know? 1 through 4, right? Because that's where the diagonals intersect. So what are 1 through 4? 90. Each one of those angles is 90. Okay. Might be easier to go ahead and kind of fill in as we go because we're going to need all of these. Now, you don't necessarily have to go in order. We don't have to fill in angle 5 if we can, but I actually don't think we can fill in angle 5 right now. So instead, okay, instead, let's just pick out a triangle. So let's do, I could probably do angles 9 and 10, right? Okay, so look at angle 10. So if you look here, see this little mini triangle here? I know that this is 90, this is 46. All three of those together are 180, right? So 90 plus 46 is going to be 136. 180 minus 136, so angle 10 should be 44. And I can do pretty much the same thing for angle 9, but different angles, right? So this one instead is going to be, right, this triangle right here, so it's going to be 34, 90, and 9. So this time 34 plus 90 is 124. 180 minus 124, angle 9 is going to be 56. With me so far? Okay. Now, the rest of it I could probably fill in by using either congruent triangles or, do you guys remember, isosceles triangles? Isosceles triangles are going to be super, super useful. So what I have here, if you look at the big triangles here, okay, and there's so many other ways that you can find these angles. This is just what I do, okay? Okay, so you see this triangle right here? That's an isosceles triangle. Do you remember what we know about the angles opposite the congruent sides? Remember? The angles opposite the congruent sides are congruent. So if angle 10 is 44, guess what angle 8 is? 44. And we can do the same thing for angle 7, because this, over here on the left-hand side, this is also an isosceles triangle. So if angle 9 is 56, what's angle 7? 56. Now for angles 5 and 6, if you wanted to go through the process here, you could prove that, you could do these two triangles are congruent by side, side, side. Right? The top triangle would be congruent to the bottom triangle by side, side, side. So CPCT. So if this angle is 46, angle 5 is also 46. And if that angle is 34, angle 6 is also going to be 34. You'll have, I think, one that's like that. Kind of a lot to that one. Okay? All right, last few questions. Kind of similar to number 3, kind of. Okay, so number 6, let's say first, okay, we're going to have an isosceles trapezoid, which means we know that those legs are congruent. Okay, this bottom angle down here is 60, and this angle over here is 3x plus 15. Now, since this is an isosceles trapezoid, What do I know about those angles? They're base angles, right? They share the same base, so they are congruent. So 60 equals 3x plus 15. So subtract 15, so 45 equals 3x. Divide and we should get x equals 15. Okay, last one. Okay, so number 7 is going to be a kite, but for this kite we're just going to have one diagonal. But we still have those congruent sides. Okay, this top angle is going to be 3x plus 5. This bottom angle down here is going to be 2y minus 20. The very bottom angle will be 4x minus 30. And then this angle right here will be y. So what I kind of do whenever I'm working through these is I'm like, I would guess that this is probably true, and then kind of backtrack and see, okay, do I know like for certain that it is true? So what's something that you could maybe guess that could help us solve these? That's kind of what I started with too. I'm kind of thinking, I think those are congruent. They look congruent, which isn't enough to prove that. So then I need to kind of backtrack and make sure I can justify that. Any ideas on how I might be able to justify that those angles are congruent? Do what? Now for a base angle, that's for a trapezoid, and this is a kite. I could prove that these two triangles are congruent, right? Because I have side, side, and then the shared side. And if I know these two triangles are congruent, we have that CPCT, which means the corresponding parts of congruent triangles are congruent. So that's how I know that 3x plus 5 equals 4x minus 30. So subtract your 3x, so you have 5 equals x minus 30. So x equals 35. Now, to find y. Now, originally, right out of the gate, I'm like, oh, well, those are equal too. But that's not true because they're not corresponding parts, right? If you were to look, what angle corresponds to this one right here in the other triangle? The one like right above it right here, right? What I could do, though, is I could say, well, then this angle is 2y minus 20. Well, I don't know what 2y minus 20 is, but it's 2y minus 20. So look what you have in that top triangle. I mean, you have all three angles, don't you? And actually, for this right here, could you figure out what that is? We just found out what x is. X is 35. So if I do 3 times 35 plus 5, you get 110. So if that angle's 110, that angle's y. That angle's 2y minus 20, I could probably solve for y, right? So y plus 2y is 3y. Negative 20 plus 110 would be 90. They're the angles of a triangle, so they'd have to equal 180. So 3y equals 90, so y equals 30.